Hello, this is Module 5 Video 21. In this video we're going to build a string literal parser. Okay, so first of all, what do I mean by a string literal parser? What I mean is the ability to take as input a string literal wrapped in quotes and then parse out just the string portion of that input. So let me show you what that looks like in terms of an API. Let me create a folder here first to hold all our parsers in a separate namespace. And I'll put it in a string literal parser class. Now all these parser classes can be internal and static. Now the API I'm after is going to look something like this. Now this parser type here is a type provided by Sprash, so I'm going to have to add Sprash as a package. Okay, Sprash is added, so I should be able to resolve this type now. I can. So the idea is we're exposing this static field called parser, and it will implement a parser that takes in some kind of input and gives us back a string that represents the literal string inside that input. And of course, if there is none or there's an error trying to resolve that string, then the parser will surface that error. And probably the best way to get into this is to start with some tests, just to really show what it is that we're trying to achieve, what it is that our parser needs to do. So let me write some tests. Right, so here are my tests. It's worth walking through these just to be clear about what we're trying to build here. So first test is can parse single quoted strings, and I'm using NUnit's test case functionality to pass through these parameters here. So the first parameter is what is being input to the parser, and then the second parameter is what we expect the parser to give us back. So in this first test case here, we've got an input of just two single quote delimiters, and what we expect back is an empty string because there's no literal string inside those single quotes. Second case, we do have some white space inside the single quotes, so we expect that white space back. Third case, we've got hello, and we expect back a hello. Fourth case, we've got world. Again, these are all inside single quotes, and that's the important part because we're trying to parse out a string literal. And in this case, we're checking that we can delimit those string literals with single quotes. And then the last test case here, we've got some white space, hello, comma, world, exclamation, and then some more white space. And we expect to get back all of that, including the white space. And then we've got a very similar test case, except I've changed the single quotes to double quotes, just to prove that we can parse string literals with either. And then this third test here can parse escaped strings. We've got some string literals that have a backslash in them and followed by the delimiter. So in this case, we don't want this delimiter here to end the string literal because of the backslash. We want to include that literally in the string literal. So this is the expected result: hello friend with friend in quotes. And we've got another test case here to check the double quotes work as well. Cannot parse empty input. So if we give the parser an empty input, string.empty, then we expect it to be unsuccessful, and we expect to get a decent message back from the result, inside the result of parsing. Now you see here I've used parser.parse and then passed in the string, whereas here I'm passing in a new input object directly into the parser. That's so that I can get back a richer result object here. It's iResult of string, whereas this will just be a string. And the iResult type gives us, this was successful as well as a message. So the next test, cannot parse non-delimited string. So if we've got a string that we pass in that doesn't have any quotes around it, then obviously we shouldn't be able to parse that because we're trying to parse string literals. And in this case, the parser should fail and just say it wasn't expecting, the first character of that text. Last test here is cannot parse non-terminated string, in which we've got a bunch of strings that start off with a delimiter but don't have a terminating delimiter. So we've got a message of unexpected end of input. So that's the test. Let's get to a point where we can build and see our tests failing. Cool, so all our tests are failing as we hoped. So now we need to implement this, and this is where we need to kind of understand a bit about how Sprash works. And in particular, there are a couple of ways you can implement a parser. One is to compose existing parsers together and then extract a result from the combination of those parsers. Another is to provide your own delegate that gets called when the parser is executed. And it turns out that I think for this case it's better to do that latter approach of just implementing the delegate, at least privately. So what I'm planning to do here is have a private method here that looks like this. So that method will get us a string literal parser. Maybe I should call that string literal parser for a given delimiter. And then what we can do is we can compose together two of those parsers using OR. Like that. So what we're saying is a string literal parser has a parser, and that parser can parse either string literals delimited by double quotes or string literals delimited by single quotes. So the real work here is inside this getStringLiteralParser. And the way I'm going to do that is just to return an anonymous delegate. I here represents the input. Okay, so here's the code I've come up with. First of all, we're checking whether the input is at the end. If it's at the end already, then obviously that's not expected. We can't parse a string out of that, so we return unexpected end of input failure. This last argument here is informational. It's kind of what did you actually expect? So we're saying we expected a string. Obviously, I was expecting to format that, but I didn't need to, so I'll just remove that. Well, what I was thinking was it would say string delimited by and then delimiter, but yeah, I think that makes sense, because then when we compose multiple of these parsers together and they all fail, then you'll get a list of expectations like string delimited by single quote, string delimited by double quote. And I might leave those quotes out just to avoid confusion. Okay, and then we are checking whether the current character is not the delimiter, in which case we can't actually parse a string literal because it needs to be, right off the bat, it needs to be the delimiter. And then we just say, well, unexpected, and then whatever character we did get. Okay, and then we're at the point where we think we can probably parse a string literal, so we create this builder here to avoid concatenation. And we've got this escaped property, escaped field here to tell us whether we're currently inside an escaped bit of the string. Then we loop while true and we advance the input, check it for at the end. If we are, then that's unexpected because we never closed the delimiter, as indicated by the expectation here. We expect either the string to continue on or we expect a delimiter. Then we check whether the current character is a backslash, in which case we're trying to escape, or if we already are escaped, then we append the backslash, because you can escape a backslash as well. So actually I will simplify this a bit. So if we were already escaped, we append the backslash and then we reset escaped to false and then continue with our loop. Otherwise, we weren't escaped, so we need to set the escaped to true. Now, if it wasn't a backslash, but it is a delimiter, then we have a check whether we're escaped. If we are escaped, then we append the delimiter, which is the current input character. We reset escaped and then we continue. Otherwise, we advance the input and break because we're done, because we've found the end delimiter for the string literal. And if it's not a backslash and it's not a delimiter, then we just set escape to false and append the character. A lot of the time escaped will already be false, but in the case where we've got backslash delimiter, then we need to make sure that we do reset the escaped variable. And then finally, assuming we hit this break here, then we return result.success and we pass through the string literal that we parsed and the rest of the input. So this is kind of how Sprash works, is that you advance the input as you're parsing it, and then in your success result you pass through where you were up to in the input. So let's try running those tests with this implementation. A single failure here. Of course, because we're not actually supporting tabs. Sorry, we're not supporting escaped tabs. And to be honest, I'm not going to bother. I don't know why I added that test case. I was thinking about C# string literals rather than the string literals that we care about. So I will just remove those. This one was wrong as well. 1, 2. And try that again. Okay, now we're passing. So that is our string literal parser, and most of our parsers will not be implemented in this fashion. Just because it's such a low level thing, it makes more sense to me to kind of just do it as a delegate instead of trying to compose together, character parsers, and it gets a bit messy if you got, we need to support escaping and all that kind of thing. So I thought it'd be easier to do it as a delegate, and I think it probably is. It's easier to follow as well. But I think the rest of our parsers will be higher level and composing together other parsers, but don't hold me to that. Anyways, I will see you in the next video. Goodbye.